Students, we're talking about designing habs, places to live on these other planets, other moons, on these other worlds. So we've just seen a video about this Marcia design. It's got all sorts of layers, all sorts of things in there. You know, living, wow, like this on Mars, could that really happen? Or maybe we're going to be underground, something more like this. But the point here is, what is it going to take to build these things? And that brings us to our lesson today about natural resources. So let's start with what that means. A natural resource, something from the environment, resource, something that's useful. So useful stuff, things from the environment that we do something with, also called raw materials. It's a very popular phrase for that. You could perhaps call it an environmental resource as well. Some of these resources are renewable, some of them are non-renewable. I want you to think right now, what is a non-renewable resource you know of on Earth? I would think most of you came to thinking something like coal, oil, or natural gas, the fossil fuels. Think of a renewable resource. Popular answers there would be something like sunlight. All right, just to clarify, a crop is a natural resource that we farm. It's specifically plants that we use for something. Most of them we eat, but some of them we don't. We don't eat trees, we don't eat cotton, but nonetheless, these are plants that we need. Sustainability is a very, very crucial thing to consider, not just here on Earth, but very much here on Earth. But if we're gonna go live on one of these planets or moons, what we're doing has to be sustainable, meaning that we are using our resources responsibly. We're using them at a rate in which they will still be available in the long run. Sustainability, you can also think of as eco-friendly, earth-friendly, tree hugger, going green, all that kind of stuff. Now, mathematically, scientifically, we define this as the resources we're using. If we can calculate them to be available for 7 human generations into the future, it's about 150, 175 years, then that is sustainability. But so much of this comes down to how we harvest them and how we use them. So sustainability is really tied to renewable and non-renewable resources. So like, how quickly does the resource we're using replenish itself versus how fast are we using it? So something like sunlight replenishes itself every 24 hours. And we are not using enough of it. We could be using so much more sunlight, and it's not going anywhere. Now, fossil fuels, the rate at which we are currently using them and the amount that is present on Earth and the tens to hundreds of millions of years it takes for those things to form, well, guess what? We are going to be out of, let's see, it's oil and natural gas will be out of within 60 years. Coal, we've got about another 100 years, but nonetheless, those are going to be gone. So sustainability of our energy resources is not just about saving the earth, climate change, going green. It's about our energy grid. We have to have alternative energy sources to sustain out into the future. But anyhow, so sustainability, when we're on something like, you know, colonizing the moon or Mars, there's no option there. You cannot survive without sustainably using your resources. But then also, y'all, when we get to these places, what is even available? And that's what we're going to be focusing on today. Okay, real quick, harvesting resources, just how we get them. These are 7 common terms for that. These 4 are ways we get plants, animals, that kind of resources. These are how we get things like rock and mineral resources. Any of these things are neither good nor bad. It's all how they are done. Are they being done responsibly, sustainably, or not? A word, and I would like to think you've heard of all these things. You know what they are. Look up images if you don't know. But fracking, I just want to bring to your attention. All you really need to know right now in this semester is that fracking is a method to get coal or natural gas. We will talk a lot more about this next semester, but all you need to know now is it's something that we use to get coal and natural gas. Speaking of fossil fuels, just make sure we're all on the same page of what that means. Here's some images of fossil fuel stuff. This is some drilling practices right here. That's oil on water. That is not a fossil fuel picture. That looks to me like a nuclear power plant. Hey, maybe it's mislabeled. Anyhow, this looks more fossil fuel related, but okay. And there's some coal. It's a picture of coal. All right. Anyhow, okay. This next question here to consider: as we go to these worlds, these moons, these planets, if the resource isn't there, like if we want to use fossil fuels, and guess what? Fossil fuels are not there, particularly coal and oil, 100% not going to be there. The natural gas might actually, but okay, when we get to these places and they aren't available, what are we going to do? We can use an alternative material, like an alternative to oil, could be something like solar power. Or we bring it with us. Can we bring these fossil fuels with us? Or the whatever else we're talking about, be it plastic, cotton, whatever material we're talking about, could we bring it with us? So if we bring it with us, some of the pros there is, well, then we have it. The drawbacks, the cons, the quote unquote stealing from Earth people, that depends on what resource we're talking about, and are we actually taking it from Earth or are we taking it from somewhere else? But there are some ethics involved there, and taking it from one environment to supply another environment, you will need to consider those kinds of ethics. But the biggest drawbacks to taking stuff with us is that it literally takes up valuable space on the ship, and we don't necessarily have enough room to take things with us depending on what it is we're talking about. But perhaps more importantly, is this fuel needed? Okay, imagine you have a pebble in your hand and you can toss that pebble around. You can move that pebble easily. Imagine there's a boulder on the ground. You can hardly budge the boulder. It's too heavy. It requires so much more energy to push that big boulder, that heavy, heavy boulder. So here's what I'm getting at. When we talk about rocket science and launching things off this planet, it takes so much energy, so much fuel resource to blast things off this planet, to get those rockets going. Well, we cannot pack things that are all that heavy. The biggest resource that comes to mind with this is water. It is not scientifically possible to take enough water with us for everything we need to do, particularly the farming, because water is too heavy. And if we bring more water, we need the fuel to push that water. Well, fuel has mass. The more fuel we pack, then we need even more fuel to push that fuel, and then more fuel to push the more fuel that we bought, that we're bringing, and we end up in this loop where it's actually not possible to continue. So we cannot pack everything with us. So is it going to be available on the places we're going? Well, something like water, really, it's got to be there. But there are a couple of options, such as mining the materials from asteroids or comets. And now I want you to think back to some stuff you've previously learned about our solar system. In our solar system, there is the inner solar system, there is the outer solar system. In the inner solar system, over here is where the asteroids are. Far, far, far away is where the comets are. The comets are out here in the Kuiper Belt. I know it looks like it says Kuiper, but that thing past Neptune is the Kuiper Belt. Now, what have you learned about the formation of a solar system like this? There is a previous star, that star goes supernova, it dies, and it makes what kind of elements? So those heavy elements versus the lighter elements. Where in the solar system are the heavier elements, the things that form rocks and minerals, the metals, where are those? Versus the lighter elements, the things that make up water, H2O, gases such as carbon dioxide, gases such as methane, which is CH4. Those heavier elements versus the lighter elements. Thinking, ding, ding, ding. Yes, you know this. The heavier elements are in the inner solar system, where the asteroids are. So that's where we're going to find things like rocks and minerals and metal resources. in the outer solar system where the comets are would be the water and the atmosphere material. So as you are designing these plans for your HABs, if water and atmosphere is what you need, you'd be better off getting that from a comet. If metals and rocks and mineral material is what you need, you'd be better off getting that from an asteroid. But you still have to consider, is it even possible? I mean, if you're going to Mars, the comets are really far away from Mars. Could you actually go get them? So anyway, things to consider, real world things to consider. Is it possible? All right, moving on. The next couple of pages, what this is, how this is set up is I've listed several really important resources that we absolutely depend on here on Earth. Things you need to consider as you move to these other worlds is, do you have that available? And if not, then what are you going to do? Fuel, we need for energy. The main natural resource here on Earth are fossil fuels, the oil, coal, and the natural gas. Chemically, these are all hydrocarbons, hydrogen, carbon, hydrocarbons. That's scientifically important to know because your planet, by the way, will not have fossil fuels, but will they have hydrocarbons? Think about this for a second. What is a fossil? A dead thing, something that used to be alive. Oil comes from animal stuff, coal comes from plant stuff, natural gas comes from bacteria. Natural gas, can come from any of them, from bacteria, from fungus, from animals, from plants, from any of it. If these worlds we're moving to didn't have thriving life, they're not going to have fossil fuels. So generally, is it available? No. So what kind of alternatives are you going to do? This is one where we can't bring it with us. This is not something we can harvest from an asteroid. It's not something we have enough space and mass to take with us on our ships. So we'll use an alternative material. If you're in the inner solar system, if your group is planning for Mars or the moon, solar power is going to be your main thing because it's available in the inner solar system. In the outer solar system, if your group is planning on Titan, Enceladus, or Ganymede, there's not a lot of solar power out there, but hey, those 3 moons have hydrocarbons available. Fuels, things such as methane. Methane is natural gas, but now natural gas on Earth is produced biologically through living things. On these moons, it's not likely a living thing. Okay, maybe, we still don't know yet, but there are hydrocarbons there. Other things going on is tidal heating. You will need to look that up if your moon or planet has it, if your moon has it, but basically that is the gravity of the moon. It's the gravity of the sun pulling one direction on that moon versus the gravity of the planet it orbits, Jupiter or Saturn, pulling it on another direction. It's being pulled this way by the sun, pulled that way by the planet, and it wah, 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 wah on the inside, and creates some internal heat, which ding, ding, ding actually leads to the possibility of a magnetosphere, depending. Okay, anyway, the other thing you have available on those planets is going to be wind energy. Potentially on those moons. All right, plastics. Plastics we use so much in our lives. You can read there, you can think more. Surprise, plastic on Earth comes from oil. Oil is a fossil fuel. It is a carbon-based molecule. Oil is not available where we're going. Alternative materials, there are plant-based plastics. We can use plant-based plastics because plants are these hydrocarbons, these carbon-based life forms, so we can use plants to produce plastics. But plants are not already growing on any of your planets or moons, so you would need to grow the plants. You need to figure out a system for growing these things. Windows. Here's what's really important you need about windows. You've got to have something to maintain air pressure in your HAB. Airlock doors, pressurized windows. You've got to make it so that the gas doesn't escape. But you also are going to need something for sunlight to come through because you're going to have plants growing. We need the plants for things like this and for food. So you've got to have something that will let sunlight through but maintain the air pressure, the internal air pressure. Glass on Earth comes from sand. Sand is a silicate, as in silicon. The ATE at the end of the word implies that it's bonded to oxygen. It's silicone and oxygen. So what you're going to need to know for where you're going Are there silicate-based rocks? Are there silicate-based rocks? For instance, on Mars, basalt that is there is a silicate-based rock. Alternatives, for those of you that don't have silicate-based stuff, glass can be made from, well, something like glass, a polycarbonate glass. Carbon, ATE at the end, oxygen, plant-based window-type things. And even if you are going to somewhere where, like Mars, where there are silicates, the polycarbonate glass might just be better anyway. It holds better pressure. It's less likely to break, that kind of stuff. Steel. Steel is so ubiquitous, meaning everywhere in our lives that you don't necessarily realize, but some of the biggest things that are made from steel that, like, oh, wow, that matters. Large buildings, like the frame of the schoolroom building I'm sitting in right now. Tools, machines, the machines that might build our buildings, they're made from steel. Steel is not an element. It is not a metal. It is something called an alloy. Alloy means mixture of metals, or metal plus something else. Metal belongs on the periodic table, and alloy does not exist on the periodic table anyway. But what's more important that you realize is steel is iron plus carbon. There are various kinds of steel, like medical grade steel, stainless steel. They have slightly different recipes, but generally that's what steel is. For this, a lot of this you're going to be bringing with you, like tools and some of the machines. You might send the machines ahead of you before the humans get there. Tools, send them ahead of you, bring them. A lot of these are going to be sourced from Earth, but also in the long term, like the stuff you send beforehand is just to set it up before you get there. The long term, like hundreds, thousands of years down the road, you're going to need to be able to produce your own actual steel or things that will, cover all these purposes. Concrete, I really just want you to think about building materials, not necessarily literally concrete, but what are your homes and buildings and structures going to be made out of? So general rocky material. Concrete specifically is made out of limestone. All right, so look into your planet or moon about that. Fibers, clothing, blankets, commonly made from cotton, which is a plant, wool, which is sheep, polyester, synthetic materials are actually made from fossil fuels. Yes, you're wearing fossil fuels. It's insane to think. So what are you gonna do for that? All right, electrical wiring. You may have already figured out your energy, but that's great to have a solar panel, but you got to get the energy from the solar panel to power your devices. You will need electrical wiring. If you look up what metals your moon or planet has, if it has metals at all, great, just Google search to make sure that those metals can conduct electricity. If you're headed out to those outer solar system moons, you're not going to have metals that are accessible to you. You're probably going to need to bring them with you. So look into what amount of mass can you take with you, which metals are you going to take with you that are ethically okay to take from Earth in the amount you will need them. Computer chips come from silicone, sand, and oxygen. There may be some other metals, but we need our digital technology. This is one where we can pack so much information in such tiny little computer chips that wink, wink, nudge, nudge. You can honestly just take this from Earth for the short term. For the long run, though, hundreds and thousands of years down the road on these other worlds, you're going to need to figure out how to make them there. But to at least start your hab, just take it with you. Water. Please make sure your group has considered water. I really don't need to go into why we need that and what it's made out of, but there it is. Soil. Soil is so important because we got to eat and we need to grow the plants to be those carbon-based sources for so many of the other materials we need. Here's the thing about soil you may not know. Well, the part you do know is that soil is made of broken down rocks. Regolith is the word that has been mentioned in some of the videos that we've watched. If you're Google searching for your moon or planet, does it have the rock material? You're going to want to check for that regolith word. But the other part of soil, the part that makes it healthy, the part that makes it possible for plants to grow out of, because surprise, a pile of rocks, plant ain't going to grow. The other part of soil is organic material. Poop, bacteria, fungus, dead stuff. you will have to, every single group is going to have to source this. And hey, guess what? We already made you think about carbon cycle, nitrogen cycle, and phosphorus cycle. If you didn't already realize, you have to have a compost pile as part of your setup. You've got to have that. Go back and figure that out on your how do Earth's resources cycles make resources. Composting, it basically you're not doing your project right if you do not include composting. If you don't know what that is, ask your teacher, do a little bit of a side lesson, look things up. That's a conversation for a different lesson, but is mandatory. Okay, and this one's not on your document, oxygen. Please consider your oxygen and what do you have breathable oxygen. If your planet or moon has oxygen locked in the rocks, okay, but we cannot breathe a rock. So you need to think about where the breathable oxygen is coming from. All right, great luck. Ask for help as needed and work with your groups. By the way, to get the rest of all of this filled in, and then turn in these notes filled in as an assignment.